On the dusty red plains of Mars, China's rover Zhurong has done something incredible. It found hidden layers beneath the surface, secret pages of the planet's history. What makes this even more amazing is that even big giant like NASA tried exploring these areas before with missions like the Mars Polar Lander and the Mars Climate Orbiter, but both failed. Yet Zhurong made it, quietly revealing secrets that no one else could. So, what did Zhurong really find beneath Mars's surface? Let's find out. The journey began on 23 July 2020, when a Long March 5 rocket launched from Hainan, China, carrying Tianwen-1, a spacecraft that combined an orbiter, lander, and rover in one ambitious mission. Over 202 days, it traveled roughly 470 million kilometers across the void of space, finally entering Mars orbit on the 10th of February 2021. Every maneuver had to be precise. A single miscalculation could have ended the mission before it even began. 3 months later, on the 14th of May 2021, the lander touched down in Utopia Planitia, a vast northern basin of Mars. With this success, China became only the second country ever to operate a rover on Mars. Zhurong was named after the mythological Chinese fire god. Standing 1.85 meters tall and weighing 240 kilograms, it was loaded with advanced instruments, panoramic cameras, a multispectral imager, magnetic sensors, and critically, a ground-penetrating radar designed to probe deep beneath the Martian soil. Originally designed for a 90-sol mission, about 3 Earth months, Zhurong exceeded expectations, surviving dust storms, freezing nights, and traveling nearly 2 kilometers over more than 350 Martian days. But what did Zhurong actually find under Mars' dusty plains? Its radar revealed something extraordinary: 76 distinct layers beneath the surface. At first, scientists weren't sure what to make of them. Could these just be random soil variations, ice boundaries, or even errors in the radar data? Further analysis suggested otherwise. These layers resemble geological strata formed by water-related processes, ancient shorelines, floodplains, or frozen sheets of briny water. Spectrometers detected hydrated sulfates and salts, minerals that only form in the presence of liquid water. This evidence strongly points to Mars having been wet far more recently than previously believed. So, is Mars really dead? The radar data, combined with surface studies, suggest otherwise. Some of the youngest layers may have formed as recently as 400,000 years ago, a time when early humans were already walking the Earth. In planetary terms, that's almost yesterday. Mars may have had liquid water flowing, freezing, and refreezing within just a fraction of its long history. The idea that Mars has been completely frozen and lifeless for billions of years may be wrong. How could water exist so recently on a planet we think is cold and dry? Mars has complex climate cycles driven by its orbit and axial tilt. Every 100,000 years, the planet's orbit swings between circular and elongated, altering seasons dramatically. Its axial tilt, currently around 25 degrees, fluctuates between 15 degrees and 35 degrees over hundreds of thousands of years, melting polar ice and sending water vapor toward the equator. Mars also precesses a slow wobble of its axis that shifts warm and cold zones across the planet. These cosmic gears create cycles of melting, flooding, wind shifts, and sediment deposition. Zhurong's 76 layers may be snapshots of this planetary heartbeat, each marking a cycle of water flow, freezing, and deposition. Some skeptics argue these layers might not be water-related at all. Could they be ice, rock boundaries, or radar artifacts? While caution is important, the combination of layered radar patterns, hydrated minerals, and young surface features makes a compelling case. These are not just random formations. They appear to record repeated episodes of water interacting with the Martian surface, leaving behind a layered history of the planet's recent activity. Why is Utopia Planitia so important? It is a vast, flat northern basin with high scientific potential and engineering safety. Its sediment-filled plains and shallow basins make it ideal for studying ancient water flows. NASA Viking 2 once landed nearby decades ago, but it lacked the instruments to probe beneath the surface. Zhurong, with its ground-penetrating radar and spectrometers, opened a window into layers that were previously invisible. It discovered that Mars's northern plains were not just ancient and lifeless. They may have been active, with water cycles persisting until geologically recent times. This discovery has huge implications. If water was present in these layers, even as salty slush, then the possibility of habitable conditions is higher than ever. On Earth, shallow seas, shorelines, and delta-like environments are hotspots for microbial life and are excellent at preserving fossils. Could Mars have supported life in these settings? Perhaps. Even a tiny microfossil or organic molecule from these layers could rewrite our understanding of life in the universe. China is already planning to take the next step. Tianwen 3, expected to launch around 2028, will attempt the first sample return mission to Mars, targeting areas like Utopia Planitia or Chryse Planitia. A lander will drill into the surface, collect samples from different depths, and seal them in sterile capsules. An ascent vehicle will rendezvous with an orbiter, which will carry the first Martian rocks and soil back to Earth by 2031. For the first time, scientists worldwide may be able to study physical evidence of Mars's climate history and possible signs of life. Meanwhile, Earth-based preparations are underway. Mars Base 1 in Gansu Province simulates Martian terrain, pressurized habitats, greenhouses, and dust storms. Mars Camp in Qinghai trains astronauts and engineers in survival, isolation, and system maintenance under harsh conditions. These facilities are part of China's broader long-term Mars strategy, which includes human missions between 2033 and 2043, testing life support, landing, ascent, and resource utilization technologies such as extracting water and oxygen from Martian soil. Zhurong's discoveries also challenge assumptions about Mars's timeline. For decades, scientists thought the northern plains were dry and frozen for billions of years. But the radar layers, young dunes, and hydrated minerals suggest activity within the last few 100,000 years. Mars's recent history may be far more dynamic, with cycles of flooding, freezing, and brine formation recorded in these 76 layers. It forces a re-evaluation. Mars is not a static, dead planet. It may have been habitable in the recent past. So, is life possible on Mars? While Zhurong cannot answer that definitively, its discoveries set the stage. If Tianwen 3 returns samples with preserved organics or microfossils, we could hold direct evidence in our hands that would revolutionize biology, planetary science, and our place in the cosmos. Even without life, these layers tell a story of a planet alive with climate cycles and water activity far more recently than anyone imagined. While China's approach to Mars is careful, methodical, and state-driven, across the Pacific, another contender is racing toward the same goal: Elon Musk and SpaceX. Musk dreams of a self-sustaining Martian city with 1 million people by 2050, supported by a fleet of starships, each capable of carrying 100 tons of cargo. China's strategy is centralized, slow, and highly coordinated. Fewer risks, fewer public updates, but seamless cooperation between government, military, and private industry. SpaceX takes the opposite path: rapid iteration, public testing, and trial and error. Two very different philosophies, but both face the same challenge: moving enormous amounts of mass into orbit and across the void to Mars. The most exciting thing about China's Mars discovery isn't just what they found. It's proof that we've entered a new era, a multi-country space race. This isn't about one nation winning or losing. Every mission, from anywhere, shows that building a civilization beyond Earth isn't just science fiction. It's a challenge we can solve with engineering, money, and bold planning. Zhurong has opened a door to that hidden past, and humanity is only beginning to step through, but the question still remains the same. Is life possible on Mars?